Okay, welcome to the second part of section 5.2, direct variation. Let's start with a warm-up, reviewing what we did yesterday. In the first problem, I want you to figure out if the equation represents a direct variation, and if it does, find the direct constant of variation. Then I want you to suppose y varies directly with x and write a direct variation equation that relates x and y. Then figure out the value of y when x equals 8. So let's take a look here. In order to be a direct variation, remember it has to go into the form y equals kx. So we're going to solve the equation for y. So subtract 5x from both sides. We have 12.5y equals negative 5x. Divide both sides by 12.5, and we end up with y equals negative 0.4x. This is a direct variation, and our constant of variation is negative 0.4. In the second one, we're going to suppose that y varies directly with x, and we're going to write a direct variation equation that relates x and y. Then we're going to find the value of y when x equals 10. So we're substituting in 4 for y, 8 for x, dividing both sides by 8, so k equals 1/2. When x equals 10, we're doing y equals 1/2 of 10, which is 5. So let's take a look at some application problems with direct variation. It says weight on the moon y varies directly with weight on Earth x. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. What is an equation that relates the weight on Earth x and the weight on the moon y? What is the graph of this equation? So first of all, we're going to find the value of k using our formula, y equals kx. Now weight on Earth is x and weight on the moon is y, so 16.6 goes in for y and 100 goes in for x. We divide both sides by 100 to get 0.166 is equal to k, or approximately 0.17. Using that equation, we're going to figure out a table of values so that we can create a graph. So y equals 0.17x. We're going to just pick some values. So they've chosen 0, 25, 50, 100, and 125 for us. We multiply 0.17 by each of those numbers, and that gives us another number. So we're going to graph the point 0, 0. We put a dot. 25 and 4.25. We put a dot. 50 and 8.5, 117, 125, and 21.25, and this would be our graph. So, if we're graphing a direct variation equation, we graph it just like it's in slope-intercept form. So, I put a dot on my y-intercept, which is 0. My slope is negative 2/5, so I go down 2 and over 5 to my next point and connect them. If we want to graph the equation y equals 5x, we put a dot on 0, we go up 5 and over 1, and that's how we get our second point. If we wanted to graph the equation y equals 3/4 x, we would go to 0 for our y-intercept, up 3 and over 4, and connect our dots. So, direct variation graphs are going to look like this. They're either going to be increasing or decreasing depending on whether our constant of variation is positive or constant of variation is negative. And if we take a look at this example, remember to figure out if the line is a direct variation or not, we can also substitute in 0, 0 for our x and y. We also could solve this for y and see if it comes out to be y equals kx, and if it does, then we know it's direct variation. In this case, though, I can substitute in the zeros and see if I get the same thing on the left as I have on the right. In this case, since 0 does not equal 3, the equation does not pass through the origin, which means it's not a direct variation. Sometimes you'll be given a table, and in the table you'll be asked to figure out if it's a direct variation or not. To do this, you're going to take your y value and divide it by your x value and see if you get the same thing each time. If you do, then it's a direct variation. If you do not, then it's not a direct variation. So here, when I take 2.25 divided by a negative 3, I get negative 0.75. And when I take the negative 0.75 divided by 1, I get negative 0.75. And when I take negative 3 divided by 4, I get negative 0.75. Since all of these are the same, it is a direct variation, and the equation would be y equals negative 0.75x. Let's try a couple more. Check to see if these are direct variations. When I divide my y's by my x's in this first example, I get 1.35. So my equation would be y equals 1.35x. In here, I get negative 115, and then positive 1.15. This is not a direct variation. In this example, the same thing. I get two positives and a negative, so it's not a direct variation. This last one would be a direct variation because every time I divide my y's by my x's, I get negative 1.25. So my equation would be y equals negative 1.25x. We're going to figure out if the statement is always, sometimes, or never true. So for the first one, it says the ordered pair 0, 0 is a solution of the direct variation equation y equals kx. So when I substitute 0, 0 into the equation, I get 0 equals 0, which is always true. It says you can write a direct variation in the form y equals k plus x as long as k does not equal 0. Is y equals k plus x the same as y equals k times x? Absolutely not. So this is never true. And finally, the constant of variation for the direct variation represented by y equals kx is y over x. When you divide each side of y equals kx by x, you obtain k equals y over x. Since you cannot divide by zeros, this statement is sometimes true. If x would happen to be equal to 0, then it would not be true because we can't divide by 0. Take a look at your homework assignment. It's on pages 302 to 303, numbers 21 to 29.